So it's great to have you here, Tim. We're going to be discussing all things Rego, OPA, and Styra. But before we kind of like dive in to that topic, can you tell us a bit about like what you do, where you work, and kind of like why you're here?
Yep, sure. So, my name is Tim Hinrichs. I'm the CTO and co-founder at Styra. Styra is a company name, if you haven't heard of it. I'm also one of the co-creators of the Open Policy Agent project. And then, as a CTO, one of the things that I do is I really set the, technical vision for the company. And so our company is fundamentally about solving authorization problems for the enterprise. So I'm super excited to be here today to just chat about authorization. It's always fun. It's the thing I do day in and day out. So I've really been looking forward to this.
Yeah, and again, as I was saying, kind of like before we got started, that's I was really looking to having you kind of like on the space. It's a great thing what you're doing with OPA, with Styra, and definitely kind of like changing a bit about like the ecosystem in authorization. So it's going to be a great conversation. Let's kind of like dive into it. Again, I'm talking about things like OPA. You are the creator or co-creator of the OPA and the Open Policy Agent. You work at Styra. Can you tell us like what each of those is?
Yep, sure. So, at Styra, one of the things that we aim to do is provide a unified solution for authorization. And what that means, at least for me, is that there's so many people that are embracing cloud and cloud native technologies that when they do that, they embrace a whole new technology stack, right? You're talking about Kubernetes and microservices, new databases. You're maybe using heavily probably CI/CD pipelines, and maybe you're spinning up cloud infrastructure with something like Terraform or CloudFormation. And so, when we started Styra, kind of the observation that we made was, look, all of these different pieces of software today have their own unique way of solving authorization, right? Which is the problem of controlling, obviously, which actors, which people, and which machines can perform which actions on the software. And so we said, well, that's kind of silly. What we really ought to do is have really one core way of solving authorization that can be applied to all these different, use cases, all these different layers of the cloud native stack. And so that's really what we founded Styra to do, is to provide that unified solution to authorization and policy more generally. Along the way, what we decided sort of architecturally was that we needed a distributed implementation of authorization. And so that's kind of where OPA comes into the picture. So the Open Policy Agent project is an open source project, for those of you who haven't seen it, that we started at Styra, and then we later donated it to the Cloud Native Computing Foundation. And so the idea behind OPA is that it's really designed to be the piece of software that makes a bunch of authorization decisions. And so the idea is that you run OPA in as many places as you like within your infrastructure. You might run several instances of it on each of your Kubernetes clusters. You might run it as a sidecar next to each of your microservices. You might run it in your CI/CD pipeline to actually validate Terraform plans before they get deployed and applied. You might run OPA to solve, actually deployment questions, like where should this app be deployed? The idea is that you take OPA and it's a very lightweight process. You can run it in as many places as you like to actually make authorization decisions. And so that was we think of that as the authorization data plane sometimes. It's the thing that makes decisions all on its own. And then the other thing that we do at Styra is that we have a commercial product, and the idea behind that product is that it provides a management functionality, the control plane. It embeds a bunch of expertise that we've gained about how you solve these different kinds of authorization problems into software. And so that's kind of the data plane, that's kind of the control plane piece of that overall architecture. So that's how I always think about it. OPA, as we like to call it, is the piece of software that is responsible for making authorization decisions wherever those decisions need to be made. And then you've got Styra's product, which we call the Declarative Authorization Service, which is that management plane, that control plane, that embodiment of authorization expertise that you can use to go ahead and give you that single pane of glass into all the authorization policies and decisions that are being made by OPA throughout your infrastructure.
Okay, that's great. So thanks for giving us that high level kind of like bird's eye overview of both like OPA and Styra. So kind of like if I understand correctly, kind of like playing it back to you, you started saying, hey, like there should be, quote, a single way to do authorization. and not just a single way, but a single kind of like way to do it in a distributed fashion. So at Styra, the company, you started the open policy agent, which you later donated to open source, which means now if I want to go use the open policy agent, I can watch, see the source code, I can run it. It's free for me to use. But then if I want to go like start playing with Styra, the product, kind of like this control plane, this distributed authorization system, is that kind of like the right word, the DAS? That's kind of like where Styra comes in.
Right. Yep. Absolutely. Yep. Yeah. So definitely. I think I agreed with everything you said there.
Okay. Good. So kind of like, what is a policy engine, right? Like, what makes that different from policy as code, and how does it relate to what you're doing with OPA and with Styra?
Yep. Great. So when you start thinking about sort of enforcing policies and having a unified solution to authorization, there are a number of different components that you need. Moreover, when you start, and a policy engine is one of those components. Moreover, there's a sort of an approach that we've taken with Styra and OPA, and that's to embrace a policy as code kind of mentality and tool set to solving and providing this unified solution authorization. So I'll speak more about each of those. So policy as code is really just this idea that the policies that we write, let's say a user writes about, which Kubernetes resources are safe or which microservice APIs are permitted, or whatever the domain is. Those policies should really be codified in a file format, right? There should be a file format that is completely designed to express whatever policies are necessary to be enforced. And so I always liken this to image files, right? They're JPEGs and they're GIFs. They're dedicated file formats for representing images, just like there are dedicated file formats for movies, right? MPEGs. So what we're saying here is that policy as code is kind of this idea that policy shouldn't be, hidden in the somehow in Java or Rust or whatever language you're implementing your system, and rather you should be able to take those policies and decouple them, pull them out, and express them in a dedicated file format. So that's part of policy as code that is sort of embodied by the Open Policy Agent project. So OPA includes a definition for a file format that allows you to express whatever policies you care about. OPA also includes a policy engine. The goal of that policy engine is to be able to take the policy file format. You load that file, any file that you like, into OPA, and now OPA can go ahead and process and make policy decisions based on those files and the inputs that it's handed. And so that's kind of the second piece of policy as code, the second piece that is part of this open source OPA project. The third piece that I would say goes right along with policy as code is making sure that we have enough tools to be able to do things like author policy, to test policy, to debug it, to profile it. So sort of the same ideas, so the same kind of tool chain that we have for programming languages that many of us know and love, or maybe not love, should be available for helping us to understand and write and debug our policies. And so that's kind of the third idea. There's a file format, there's a policy engine that understands that file format. There's some tools that sort of round out that experience. And then also as part of OPA, and this may go beyond the sort of basic policy as code paradigm, OPA has a bunch of integrations with existing and popular, typically open source, but not always, projects where you can use that OPA file format to express policy, and then you hand it over to the OPA that is integrated into that third-party project, and away you go. You've actually used the OPA policy language to describe and then enforce the policies that you care about in the real world.
That makes sense. So this is kind of like a policy-specific language, right? Like when we're talking about a file format to express these policies, this is, again, as you say, just like Java, just like maybe Python, but again, different syntax, different grammar, naturally different meaning, different semantics. But all that's doing is just kind of like laying that foundation of like, hey, this is my logic for policies. Then OPA comes and runs that. It's kind of like a runtime, regardless of like how it runs it. And that's kind of like you separate the two. And then on top of that, if you think about the regular programming language that we're all used to, you have an IDE, you can play that, you can debug, you can set breakpoints, you can test. all of those things, all of those pieces that you mentioned are like authoring, profiling, and testing. That would be kind of like the IDE and everything development tooling around that policy language. Is that kind of like a good analogy in that regard as well?
Yep. I like that quite a bit. And then the only thing that I'll sort of add on to that is how that relates then to Styra as a whole. And obviously we're working hard to make sure that OPA is incredibly successful, defines that policy as code framework completely on its own, and then obviously as part of that management and control plane piece, then we obviously take all those tools, we bring them together, we give you a vertically integrated kind of end-to-end solution that sort of brings that vision of that single pane of glass into reality. And so just to finish off your question there.
Yeah, that makes sense. So one of the things you mentioned was, again, not having your policy logic, not the policy code itself, but the policy logic hidden in your app, right? You don't want to have if statements all over your, again, PHP, Python, Java application where you're implementing authorization decisions. It's a good thing to have those like offloaded, and that allows you to do kind of like a number of things, but basically it's not obscure. How did you kind of like ideate? What are the origins of OPA and Styra?
Sure, yeah. So, before we started Styra, the founders we were at VMware, and we'd come into VMware through an acquisition through Nicira. So it was funny, in the early days of Nicira, which was one of the companies involved in who actually coined the term software-defined networking. In the early days of Nicira, it was actually a company focused on policy-based networking. And so it happened that while we were at VMware, we were talking to a number of the current clients or prospects, and what they were telling us was that they knew we were policy people, and so what they said was, look, we've got all these different pieces of software, and they all need authorization, they all need policy, and it'd be great if there were an idea, a product, a project that would sort of give us a single unified way of solving policy sort of across all those different pieces of software. And so in the early days, one of the things that we did was we built an open source project as part of, at the time it was OpenStack, to sort of try out this idea of, what is the shape of a unified solution to policy and authorization. And at the time, what we ended up with was sort of a centralized solution. And then one of the things that we found was that if you don't know OpenStack well, it's this collection of differing teams and services that all sort of make up all the traditional silos of compute, networking, and storage, but it's all done in a software-defined way. And so we had this centralized solution. And one of the things we found was that a lot of the developers in the other projects didn't want to take a dependency on another service in order to get its authorization decision. So, if you're building a storage service, what they didn't want to do was anytime they were received an API call that said, delete this storage volume. What they didn't want to do is then make another API call to a centralized service in order to get back an authorization decision. And the simple reason was performance and availability. They didn't want to sort of basically double the number of API calls that were required to actually service that incoming API. And so this kind of observation was what led us down the road toward building this designing and building this distributed version of authorization that we've already talked about, where OPA is the thing making decisions at the edge, and then the Styra product has this expertise, this control plane that helps give you that single pane of glass.
I see. So one of the things that I'm kind of like hearing from this is that in this type of environment where, like, in software-defined networking, in many cases, your authorization decisions like have the local context, or each component has enough local context to make a decision without calling to a separate service. In that case, calling out to a centralized type service would mean a lot of overhead. So by having this, again, in this specific instance, OPA agent distributed running with each of these teams, for example, you can make the decisions in each of their team's scopes without calling out to a centralized location. And then kind of like what the role that Styra plays there is that around not just, of course, authoring these policies, but also figuring out where each policy should be distributed, right? It's not just about the authoring and the versioning, but like making sure that policies are where they should be.
Yep, I like that. Yeah, and there's this interesting sort of interplay here between centralized solutions and distributed solutions, and certainly, given our experiences in the early days when we went ahead and designed Styra's offering and OPA, we obviously we did this. We made sure that this distributed version would work for exactly those cases that you articulate, where the information that is needed to make the decision is all local, or at least it's local enough to make it locally. And then one of the things that we've done over time is sort of seeing that different use cases have different sort of data dependencies, right? Like, and depending on those data dependencies, that'll push you more or push you more towards a distributed model or more toward a centralized model. And so, one of the things that we've seen with OPA is that, and that we're starting to do now so with DAS is enabling that or thinking about OPA as a building block that has a bunch of architectural flexibility. So in those use cases where you need to run OPA as a sidecar, it's great for doing that. In those use cases where you want to run OPA not only as a sidecar, but you actually want to embed it maybe into your service because you don't even want to pay for a local host network hop, then you can do that too. If you want to run OPA as a CLI in a CLI fashion and maybe hook it into a CI pipeline, you can do that too. It's even a building block that we started seeing people use as a component in a centralized service as well. So one of the things that I think a lot of people end up liking about OPA and Styra as well is that you get that architectural flexibility. So you run your decision-making engine, that policy engine piece, in whatever architectural configuration that you want, and everybody's, depending on the app, depending on the data, depending on the policies even, may need a slightly different architecture.
Yeah, and that's one of the things that I've been seeing, as I've been kind of like researching authorization and thinking about like solving authorization at scale, is that like as you say, like agent type solutions like OPA or policy runtime is a very important building block, because there are ways in which you can express a lot of things through a centralized perspective. There are ways in which sometimes decentralizing things is useful, but kind of like being able to compose these two pieces gives you kind of like that extra flexibility where you can say, hey, there are some things that I can decentralize, there are some things that I need to centralize, but that kind of like single pane of glass, that control over who has access to what remains there because you're using all of this tooling.
Yep, totally. It's an interesting sort of journey to be on, to sort of, as you work with a bunch of the users and customers, to sort of understand and listen to them articulate why things need to be distributed or why they think they need to be centralized, and then having the technology at hand to go ahead and address those problems is part of the fun, I think.
Yeah, definitely. And again, it's a very kind of like interesting and up and coming problem, right?
Right.
So we were talking about like complementing each other and like products being complementary. How do like OPA and Styra play together?
Sure, yeah. Well, I think the first level is we've already sort of covered, which is OPA is designed to be the decision-making engine, right? It's sometimes we'll call it a host local cache of policy and any data potentially that's needed to actually make decisions. And so then what that leaves open with OPA is, well, how do you know what policies need to be distributed to those OPAs, what data needs to be distributed to those OPAs, and that's kind of the role that Styra's product plays. I'll also say that one of the other ways that they complement each other is sort of this basic structural difference, which is OPA, open source. What it's great at is solving this unification problem at the language level, at the tool level, at the framework level. It's not opinionated, right? It was designed to be this general purpose solution to authorization. And that's the way that you can actually unify authorization, is it works for all these different use cases. Whereas with Styra, and I think this is true for many of these sort of architectural separations that you see between open source and closed source, the commercial option has a bunch of our expertise built into it, so that, how do you actually write policies? How do you configure the Envoy to OPA connection? What is the structure of those policies? How do you write tests? All that expertise that we've gained over the years from working with a bunch of users and customers has been embedded into that commercial product. And like I said, I think that complementation is a natural one, where you've got these commercial options that are highly opinionated and that make things especially easy. And then in the open source world, you've got these blindingly fast, incredibly general purpose solutions.
Yeah, and I think kind of like thinking about some of the things that I want to kind of like bring up next, that not opinionated general purpose solution is what kind of like allows you to drive from kind of its origins around like some of its original use cases to a lot of the things you're mentioning today, like microservice authorization and CLI authorization, and like maybe just, again, pushing changes to Terraform cloud providers authorization. So that not having an opinion and kind of like bringing everyone in has given you a lot of flexibility. And I guess that's also why kind of lots of companies are using OPA as a building block for their platform authorization solutions.
Yep, yeah, I think so. I mean, when we set out to build OPA, we did design it from the perspective of it's intended to be a unified solution to authorization. So what's been interesting, though, is that every now and again people ask, well, what was the first use case that you all used OPA for, and then how did it migrate? How did people pick it up and start using it for different use cases? And so I remember in the very early days of OPA, one of the things that we were looking at was public cloud. How do you write policies over the public cloud to know whether or not they're configured correctly? But it turned out that one of the first sort of public talks that an end user picked it up and used it for was really microservice authorization. So that was Netflix, and I won't remember the year off the top of my head. But so that was Netflix picked it up and used it for microservice authorization. And then another year goes by, and then we see that a bunch of folks are picking it up for Kubernetes admission control. And then we start hearing more and more of these different use cases around Terraform, around even starting to see in CI/CD pipelines, and then even seeing it in even database authorization and application authorization as well. And so we see OPA being used for more and more of these different kinds of use cases, and that's obviously rewarding for us.
That's great. So for those that are listening in and also will be listening to the recording, we'll add the link to that talk that Tim is mentioning about like Netflix authorization. That's from 2017. So we'll add that KubeCon link in the recording notes. Now, again, what do you think were the main elements that allowed kind of like OPA to go from kind of like its origins in software-defined networking to all of these use cases? And again, you were there for its history, so you can probably kind of like share a good perspective with everyone.
Yeah, well, so I think there are a number of things. So the first thing, the way so there may be different levels to answer that at. So one level is sort of at the language level. And so one of the premises for OPA since the beginning has been, if you can't write the policy you care about, you're not going to be able to use it. It's going to fail for that class of use cases. And so we knew when we started that we needed enough expressiveness to handle some of the more complicated authorization policies. And so one of the things that we did, like I said, in the early days, we were looking at writing authorization policies, at least conceptually, over public cloud resources, which is very, very similar to very similar to like a Kubernetes authorization use case. And so let me talk through. So I'll talk through some of the elements that you need in a policy language that's just derived directly from looking at trying to write policies over like Kubernetes resources. So one of the things that you do, like in a Kubernetes kind of use case, is that every time any end user, any developer is trying to spin up a new resource on a kube cluster, they take that, whether it's 50 lines, 100 lines, or 200 lines of YAML that describes the new pod or the new ingress or whatever resource they're trying to create, and they hand that over to the Kube API server. The Kube API server will go ahead and hand that resource description over to OPA. And then what it'll say is, well, hey, is this resource safe to deploy onto the cluster or not? And so imagine you wanted to write a policy that says something like, ensure all of the images come from image registries that are, that have been blessed for whatever reason. That, they're safe registries. So in order to actually express that policy using, again, a general purpose policy system that hasn't had a bunch of Kubernetes knowledge built into it, you've got to be able to take that, let's say, 100 lines of JSON or YAML, and you've got to be able to dig down through that hierarchical data to find the list of containers, let's say, that are showing up in the pod. And then it's an array, after all. There may not be just one image. There may be 2 or 5 or 10 or 100 in theory. And so you need to be able to then iterate over that array of containers. And you need to be able to then go ahead and dig down through each of those objects to find the name of the image that is being actually spun up in that container. And then you've got to be able to do string manipulation on the name of that particular image to figure out whether it's coming from a safe registry or not. Okay, so what did we cover there? We covered digging down through hierarchical data. We covered iteration. We covered string manipulation. And so, if you work through some real world problems like that one, you very quickly see what kinds of building blocks you need in the language. And I've already just illustrated a couple of them. And what you'll immediately notice is that by including iteration in that list, we've jumped in terms of expressiveness far beyond all the traditional kinds of authorization systems. And we've ended up at a spot that's somewhere in between programming languages and like I said, classical kinds of policy or authorization systems. And so that's kind of the first thing that we did, was we were working through real world problems. And what that allowed us to do was sort of understand the kinds of expressiveness that we'd need. So anyway, so that exercise allowed us to put into OPA enough expressiveness in the basic policy language that we could handle these what we sometimes call configuration authorization use cases. And then that expressiveness was certainly sufficient to go off and handle microservice authorization or Terraform Terraform plan analysis, or really any of the other use cases that you see.
Okay.
So I think
Yeah, that makes sense. So it also seems like the original use case that you were thinking about, that like Kube API server needs to make a decision, required a lot of these kind of like, I would say, flexible or complex use cases that then kind of like everything trickled down for there, because you started from that like very specific concrete use case, but at the same time relatively complex in terms of like all of the things that you needed to handle.
Yep. And then the interesting bit that that you always know, but until you've actually gone through it and built the system to do it, it definitely hits you harder, which is, if you think about the different kinds of use cases, let's just take 2. Let's just take Kubernetes admission control and microservice authorization. In the Kubernetes admission control case, you've got these requirements which say, hey, I need all this flexibility, all of this expressiveness in the language. But you know what? The kind of performance demands that you have, it's okay for the policy to run for, let's say, 10 milliseconds or even 100 milliseconds to make a decision. If you contrast that with another use case like microservice authorization, one of the things that you'll notice is that microservice authorization is a much simpler kind of policy problem. You're typically looking at, a path, a URL and a method, a get, put, post, delete. You're looking at the user or the token, the claims in that token. Maybe you're looking at IPs if you're thinking about all 3 kinds of policies. But the policies you write are typically much simpler. However, the demands from a performance point of view are much higher. And so there, maybe a millisecond, is that quick enough to make a decision? Sometimes it is, sometimes it's not. And so what you see is that as you sort of work through these different use cases, you start realizing that there are different demands and different dimensions, right? Whether, in Kubernetes, it's expressive, but the performance is sort of middle of the road. In microservices, you don't need all that much expressiveness, but what you do need is performance. And so on the performance side, we've done a bunch of things that we can chat about if you like later. But anyway, so that was the other kind of thing that we took away from the design of OPA and some of the engineering effort that's gone into it to make it apply to some of these different use cases.
That makes sense. One of the things that I'm thinking about is a lot of the constructs that you mentioned are also available in programming languages. Now, OPA uses Rego as a programming language, that kind of like file format that we talked about earlier. What made you decide to kind of like build Rego? What are its origins? And what made you decide to also build a new language rather than, for example, using any programming language that might be out there for policies.
Yep, good. So, well, okay. So there's a. I'll tell you a quick story here about one of the things we tried to do. So my background, if I go back before Styra and before VMware, my background, I did a bunch of research for years in declarative languages, and so my background was, well, I would build a bunch of these different languages for network security, or for access control, or for configuration management, so on and so forth, and so when we started Styra, you might think that I was just wanting to build a new language. In fact, I took the exact opposite approach, because I built so many of these things, and I know what it takes to get these things working well and off the ground. And so what we said at the beginning was, look, we're not going to build a new one. We're just going to find a popular language that a bunch of people know and understand, and then use that. And now, one of the things that we did say at the beginning was, look, it's got to be a policy language. It's got to be something that is at least declarative. That because what we know from talking to a bunch of the clients back at VMware was that there's a broad range of people who are writing these policies, not all of which are developers. So we felt this intuitive need to have a declarative language that was, at least, if you squint, it would be a policy language. And so one of the first things we did was we said, okay, look, of all the declarative languages on the planet, which ones are most popular, most well known? And we said, it's SQL, right? That's, it's a query language. Yes, it's a database language, but it's also, you can come up with a syntax that makes it look like any declarative language that you like. So one of the things that we first did was we said, okay, let's just use something like SQL. And so what we did was we said, well, let's try writing some policy over modern cloud native resources using SQL or some variation thereof. And so what we did was we grabbed one of the public clouds and we said, hey, just run the API that lists all of the, I think it was all the servers and their security groups or whatever the construct was. And then when you get all that information, and then the idea was, well, let's write some policy over it. Well, so when you get all that information out of a public cloud, it's JSON, right? It's not relational data. It's not like rows and columns of data. It's JSON, so it's deeply hierarchically nested data. And so we said, well, look, if we're going to use SQL, what we might as well do is go ahead and just convert JSON into relational tables. And then we just write policy over those relational tables in SQL, and we're done. That seemed like a sensible thing, right? So we went ahead and tried this. And what ended up happening was that when we converted this JSON object that represented all the servers and security groups or whatever, we ended up with something like 200 different relational tables. And then we looked at those tables and we said, well, why are there so many? And what we realized was that most of them were these artificial tables that just sort of were constructed in order to represent all the hierarchy that existed naturally in the JSON. And so we went ahead and said, well, that's crazy, because when you go ahead and start thinking about how you write a policy over 200 virtual tables, A, how do you know what those tables even represent? You don't. But B, let's say you figured that out, then what you end up doing is writing SQL queries that end up basically with a large tower of joins, and all those joins are doing is reconstructing the basic structure that the JSON had originally. And so anyway, what we realized very quickly was that any cloud native policy language would need to have native support for the hierarchical data like JSON and YAML that is so pervasive in the cloud today. So when we set out to so there's more of that story, but then when we set out to build OPA and Rego, one of the things that we knew was that semantically it had to have native support for that JSON and native support for JSON.
Okay, that's a great story. I actually didn't know that, so I learned something very interesting today. Now, kind of continuing from, okay, we have a language, we have a runtime for it. How does OPA, the runtime, work? Walk us through what happens when I need to make an authorization decision. How do you invoke it? You mentioned it can be invoked in different ways and in different contexts. Yeah. And also, how does it pick the rules and the policies to run? How does it know what code to run?
Mm-hmm. Yep, good question. So when you integrate OPA, pretty much most of the integrations with OPA all work the same way, at least conceptually. So, and that's true whether you run OPA as a sidecar, as a CLI, as a centralized service. It doesn't really matter. The way this works is that the calling service, let's say that this is a Kubernetes API server or a microservice or a CI pipeline, it doesn't really matter. In all those cases, the service that needs an authorization decision basically realizes that it needs a decision. It cobbles together basically just a JSON payload, and then goes to OPA and says, "Hey, here's the input that I have that I need an authorization decision about. Can you please make a decision and return it to me?" And so conceptually, that's all that happens, right? OPA gets them a JSON object that represents the input or the thing that we need a decision about, and OPA makes a decision, returns it back to that calling service. At a high level, that's it. Now, there are a couple of things that you asked detail-wise that I'll go into. So one of which is that, what we see a lot of people do is say, well, there are a whole bunch of different policies that I care about. And now, and moreover, even there may be a whole bunch of different rules that I want to write. And how does OPA know which rules to pick, which ones to evaluate? And so one of the things that we design into OPA and that we spend a lot of time on at the Styra DAS level is helping people sort of manage those rules, understand which rules are logically grouped together, which ones contribute to a decision, which ones don't. And so the idea here is that both OPA and DAS have this ability to break all of your policies into a bunch of different components. Think of these as packages or modules in a traditional programming language. So we do that. We apply those same concepts of modularity to policy, which isn't surprising. And now when if people are using the DAS and they can actually write different policies broken into different packages for different software systems that they're manipulating. At the OPA level, what that means is that that you can load OPA with all kinds of different policies. They each have unique names. Those we call them packages. Those packages are hierarchically defined. And so now when one of those callers, the Kube API server, the microservice, your custom application code, your CI/CD pipeline, asks OPA for a decision, it actually sends, very simply, an HTTP request. And the URL that caller uses actually names the package that it wants a decision from. So there is a default way that you don't actually have to know what package you care about. But nevertheless, conceptually, that caller can sort of choose and decide what package, what collection of policy to pull a decision out of.
Okay, so the caller might, because again, you said that there's a way in which it might not need to, but it might need to know, hey, I'm interested in making a decision around this. For example, if I'm going to deploy a new type of pod in Kubernetes, I'm interested in the deploy pod type policy. And then OPA, from that context, will be able to say, okay, these are the policies to run, these are the rules that should execute. And we talked a bit about kind of how you can bundle and make create this modular constructs so that you can kind of compose them in different rules and policies. Is that an accurate depiction of things?
Yep. Very good. Yep. And what that enables you to do is, you could run OPA. If you're running OPA as a sidecar, then the kind of concept would be that there's really one endpoint that you need to hit, right? There's one policy, one entry point to making policy decisions. But if you're running OPA as a daemon, right, that means that it's got probably multiple clients sitting on that same server. And those different clients could hit different packages to get different decisions. Or if you're running OPA as a centralized service, the same kind of thing applies. And so, that concept of packages and modularity, I think, is pretty key or it's one of the enablers, I should say, for actually helping OPA run in so many different architectural settings.
That's good. So we've been talking a lot about making policy decisions, and if anyone's listening and they're familiar with attribute-based access control, that's kind of what's typically called a policy decision point in that type of architecture. So you have lots of components, and we actually don't need to go into detail there. We covered a lot of those with David Brossard when we talked about the history of authorization and ABAC. But one thing I do want to kind of get your perspective on, Tim, is XACML was this kind of policy language, was part of the OASIS standard, well, not part of the standard, but it's actually pointed to in the OASIS standard for ABAC. What do you see as the differences between Rego and OPA and XACML, beyond the fact that one is based on data log and the other one is XML?
What I usually like to do is think about up-leveling this just a bit, and I'll give you some context there, and then maybe I'll dig into some more of the details. So And I touched on this, I think, a little bit earlier, which is, when I think about the spectrum of authorization solutions that everybody that's interested in authorization has heard about. You think about role-based access control. You think about attribute-based access control. You think about access control lists, right? Which are really, I always think of that as people writing allow and deny statements that maybe are evaluated in order. You think about the IAM solutions is what I like to call like all the public cloud kind of instantiations. And then you could even go so far as to talk about, policy-based and relation-based access control. And then there's a whole history of if you go look at the research folks, they love to build and design new languages all the time. Anyway, so in that spectrum, and then at the far end of the spectrum, which we've already touched on, and I've been sort of introducing these in the order of expressiveness, at least as I usually think about them. At the far end of that spectrum, you've got programming languages, right, which are Turing complete. Any algorithm that you can write, you can express in those languages. And so I like to think about that sort of one-dimensional view of these languages and how they differ, and at least along the expressiveness and therefore the complexity spectrum. And so the way I always think about OPA and Rego is that it sits, it's more expressive than RBOC, it's more expressive than ABOC, it's more expressive than ACLs and IAM policies, at least for the most part. But it is less expressive than all those programming languages that so many of us know. And so the idea is that it has many of the elements that you see, like iteration and handling of hierarchical data that we talked about before. String manipulation, IP arithmetic, a number of those same basic features that you see in programming languages, but it's designed to be less expressive. It's purpose-built to be one of these policy languages, and therefore it's better compared to all the others that we talked about there.
That makes sense. So in that kind of like axis or spectrum from like least to most expressive, OPA would sit somewhere between like more expressive than most ABAC solutions, less expressive than Turing complete programming languages, if that makes sense.
Yep. Yeah. So I always like to get that point across, that RBOC is something you could encode in Ruby, and ABOC is something you could encode in Ruby, and all these things that we've worked with and dealt with for years and years and years, they can all they're all less expressive than programming languages. Anyway, so that was the first thing I wanted to mention. And then if you think about how OPA compares to some of these things like XACML, one of the big things that I'll say is that OPA was really designed to be a policy language. Not just an authorization language. And I don't mean anything critical there. I just mean that often when I hear people talking about authorization, typically what they're talking about are decisions that get made that are yes, no, true, false, ones and zeros. With OPA, we knew we had to make decisions that are richer than that. And so, yes, you can make Boolean decisions, allow, deny, true, false, but the kinds of decisions OPA can return are really any arbitrary JSON object. And so that could be, for example, maybe you want to write a policy that decides what rate limit to apply. Well, there you need to return a number, right? It's not true, false, it's not allow, deny, it's a number. Maybe you want to define a policy that decides where to deploy an application. Well, there you might need to return, as a policy decision itself, the list of kube clusters onto which you want to deploy this app. Even if you think about a sort of a classic sort of microservice authorization use case, even there you end up wanting to return more than simply a bit of allow, deny. You want to return something that's like that's got multiple elements. It's got it's got a bit that says, is this allowed or not? But it may have a status code. Is this a 403 or some other 400 code or 200? Is this what's the error message that gets returned? Any headers that you want to set, assuming that this request is allowed. And so that richer collection of decisions is one of the reasons that we will often say, once we introduce OPA, like in a more intimate setting, that we say that OPA is really a policy language, and authorization is an incredibly popular part of that. But that they do have different sort of goals.
Yeah, and I really like that. One of the things that I was thinking of the other day from a policy perspective, beyond that Boolean true or false, is there might even be cases where it's not either allow or deny. I might just be saying, hey, you need to prove that you are who you are, and that might require more factors for authorization, right? That's not allow, and that's not deny. That's, hey, elevate your permission set. And that's something that it's not trivial to express, of course, with true or false, but at the same time, if you take that all the way to it's not just an enumeration, but it's a decision that you're making, that decision might not be a question of does this user have this permission? It might be what should I do with this? And that's kind of like what you're getting at with, hey, I might be deploying to this cluster or this other cluster.
Yeah.
So I want to kind of like separate things a bit now and like first maybe dive a bit into OPA and the things that are coming. But before we kind of like do that, again, OPA, as you mentioned, is open source. What are the challenges of having OPA be open source, and what are the great parts about it?
Yep, great question. So, OPA's been, backstory here is that we always knew that OPA had to be open source. When you're building something like policy as code with the goal of having a unified framework for solving authorization, that kind of project, that kind of unification project, I think naturally lends itself to open source. And so we always knew it was going to be open source. Every line of code that we've ever written for OPA has been open source. And so, for us, this wasn't a thing that we even really thought about. And so beyond the sort of basic problem statement that OPA was set out to solve, what we also knew in a unification effort was that we needed a bunch of community to get involved and to lend us their expertise in different dimensions to make sure that when we're talking about applying OPA to Kubernetes or to microservices or Terraform, that in fact that we were solving the real problems and that OPA was solving the problems in the way they needed to be solved. And so that kind of thing just naturally always felt to us as though it had to be done in the community. There's so much value in getting a whole bunch of folks that are interested in the project, that can contribute to it in one way or another. That kind of expertise, there's no real way to develop that kind of expertise without this kind of open source angle to it. So I think that's all great. There's so many fun things about open source. I love being able to go and have chats like this about what we're doing. I love going to conferences, meeting the folks who are using OPA or that have questions about it face to face. Being able to give those talks. I think there's so many great things about open source that for us it was very easy.
That's great, and it seems things are kind of like on a very good track, so to speak.
Yep, totally. Yeah, do it again for sure.
Good. So one of kind of like diving into Rego, one of the things I've been seeing as part of kind of like in my research, talking to different people at different companies, different sizes, is like they're using OPA, they're using Rego, but they say something like, hey, I don't want anyone on any of my dev teams to be able to write arbitrary Rego. It's too powerful, and it allows them too many options when I just want them to kind of like build a few things. So what kind of like companies that are medium to large size, technology companies are doing, and some of them, I'm seeing that they tell me, hey, I'm building a layer on top of Rego where there are only some things that you can do, and that's what we expose to our development teams. Are you seeing that as well? And what are your thoughts about this in terms of like future features of Rego and OPA?
Yep. Well, so yeah, certainly it's a case that we talked about this earlier. We touched on it, which is that OPA was designed to define the language for unified authorization, and so we've already talked about what that means in terms of expressiveness of things you can say. And so then what I'll do is I'll sort of contrast that with how people in an org and the different personas within an organization that typically want to contribute to policy. So one of the things that we've seen, certainly Styra working with some of these folks, is that they're different people, different personas want a different interface for writing policy. So one of the things that we do in our product is we say, well, look, you can write text, and you know what? If that's what you want to do, go for it. But some people say, well, I really like to have a more guided view or a guided experience when it comes to writing policy. So I don't want to lose any of the power, but what I want to do is have sort of a GUI that's a layer on top of text that just sort of guides me through writing the policies that I actually care about. And then we found a bunch of folks who say, you know what, I don't even really want to write policies at all. I want a bunch of pre-built policies that I can pull out of a list, and then I can go ahead and maybe I can parameterize them, right? I can add a few, I can for in Kubernetes, for example, like what is the list of trusted registries? Well, if nobody on the planet can tell some random organization what the trusted registries are, so you need to parameterize those rules. We've even gone so far as to have packs of policies, like mapping PCI down onto packs of policies, and then saying, well, look, there's now a wizard interface that will walk you through putting all of these different rules in place, and each one you can parameterize, and so on and so forth. So I certainly see the value in having different interfaces for writing policy. And one thing I will say is that what we've seen is that different organizations will have different goals or aspirations, or maybe I should even say limitations around what kinds of policies they want their let's say developers to write. And so, one of the things that we did a blog post on recently was how you can use, interestingly enough, Rego to actually lint Rego code. Why? Because after all, Rego code can be converted into JSON, the ASTs, and then you can use Rego to go ahead and do that linting. And so often, and by the way, like linting sometimes means like relatively like low-level things, like do you put spaces in the right place or not? But if you really think of just linting as putting guardrails on the kinds of policies that people can write, then really linting is a pretty powerful way of getting that kind of control. And I'll say firsthand that I see different organizations wanting different kinds of policies and different linting rules effectively for their policies.
That makes sense. I actually haven't read that blog post. I'll take a look. It's probably fairly interesting to see Rego linting Rego. It's and also kind of like a good geek read pro as well.
Yeah, it's a very meta read, right? It's a very language-focused kind of audience.
So another thing we talked about earlier was like performance and latency, especially in the context of like microservices, and also in the context of like not centralizing some things when possible, when you have that context. How does Rego optimize for performance? And are there any features coming in the roadmap that maybe aren't there but you're planning ahead?
So there, for sure. So there are a few things about Rego that I'll mention here. So one of which was that when we design, if you think about sort of core design principles, one of those core design principles was around performance. So one of the things that we know, and especially maybe building on this last conversation, we've got a broad range of different people who want to be writing policy, and so what we want, one of the design goals for OPA and Rego has always been that, as a policy author, you should be focused predominantly on correctness and maintainability of your policies. And that what we want is for OPA to shoulder much of the burden for performance. Now, obviously, there's only so much you can do there, but conceptually, that kind of shared response, that kind of split of responsibilities is what we're aiming for. And so there are a couple of very concrete things that we've done to help with this. So one of which is that the language itself, you can think of it as being designed as sort of an onion, right? So there's this core part of the language that if you put policies in that core part of the language, then evaluation runs very, very quickly. And then if you go outside of that fragment, that syntactic fragment, then you gain some expressiveness, right? You can write policies more compactly or more efficiently, but you give up a little bit of the performance, and then so on and so forth. So that was one of the sort of ideas behind Rego, is that it is designed as an onion. Now, the way that we make that core element of Rego fast is we do something called rule indexing. So the idea here is that you might write. Imagine that you've already split up your policy into different packages. And so, the rules within one package, let's say you've got 100 or 1,000 allow rules for whatever reason. Now, typically we don't actually see that all that often, but that could happen, right? You could write 1,000 allow rules. And now the question is, when OPA is being asked to make a decision, how does OPA find which of those rules to evaluate? And so what we do at compile time is we effectively go and do static, OPA. OPA goes, and there are algorithms baked into OPA that will go and do static analysis of those rules. And then what it'll do is it'll organize them into a trie. And the idea then becomes that when the input comes into OPA, OPA will then go and sort of inspect the input. And by inspecting the input, it knows how to walk the trie to find that subset of rules that actually need to be evaluated, right? And so that's one very key performance feature that we put into OPA. You don't even notice it's happening because it's always on, right? There's no way to turn it off.
Yeah, just a small thing there. So for anyone listening, a trie is a prefix tree. So essentially start walking down the tree or a particular path down the tree. And that prefix is kind of like the set of rules or policies that you need to run, but not more than that. Is that kind of like how you're using it?
Yep. Yeah. That's what I meant. Yeah, and the edges here correspond to basically tests on what's included in the input. Yep.
Okay.
Yeah. So,
that's great. So one of the things we also talked about related to latency was about like microservices and like what happens when you don't have all of your data local. What for your customers using Styra, for people using OPA, what patterns do you recommend for like dealing with microservices and multiple policy information points or databases to also keep database low and latency low?
Yeah, great question. Yeah, and so this was a question that came up so often. This was years ago. I can't remember which KubeCon it was, but there was some KubeCon where we came back and we said, you know what, we got this question a lot. Let's write up some docs. And so there's a good website There's a good web page on the OPA website that sort of outlines 5 different ways of getting OPA. I think it's 5 different ways of getting data into OPA. And so this is really, I think I'll just talk through a couple of these very quickly because they aren't really dependent so much on the use case, right? These may be more or less valuable to you just depending on the data, how big it is, how quickly it's changing, what your consistency requirements are. And so one of the things that we find working with folks is that they just have these data requirements, and it's more or less independent of the use case. So one way that we always suggest people get data into OPA in order to make decisions is that you can pass JOTs, so JSON Web Tokens, into OPA, and OPA has some pre-built some native support for actually being able to inspect the internals of the JOT. And so a very common use case in the microservice world is that you got a user authenticate. They belong to 5 groups. Those groups are embedded in the JOT. That JOT is handed over to OPA, and then when OPA is making a decision, it'll go ahead and inspect the internals of that token and then make the decision appropriately. So that's if you think broadly about data, encoding that data into JOTs is really effective in terms of it's perfectly parallelizable, right? There's no real replication. There's no work that needs to happen. It's a model that we like quite a bit. Anyway, I'll be quicker on the other ones. You can also go ahead and load data, arbitrary JSON data, into OPA through bundles. So bundles are just this distribution mechanism that OPA and Styra DAS support. OPA supports it on its own, DAS supports it on its own. It works with OPA, but one of the things we try to do there is that's really great for like static and medium-sized data that'll fit into memory. And so, like with DAS, one of the things we can do is go ahead and fetch all kinds of different data from different places. Customers can push it in, and then we'll just go ahead and be responsible for distributing that to all the OPAs. The other kinds of data or the other kinds of ways of getting OPA data would be setting up like a watcher, like a streaming kind of service that's running as a sidecar next to OPA, let's say, and then pushing data into OPA's API. You can do that. You can also use OPA's has a built-in that will actually go and allow you to reach out to other HTTP services and go ahead and fetch data and bring it in and then make policy decisions using that data. I feel like I'm missing one, but no, I think I got them all. So that's kind of what we see.
And I think, I think there's also kind of like a caching mechanism where like some of the previous data you might have used, you might be able to reuse, something like that.
Well, there's caching with the HTTP send. So, sorry, that's the built-in. That's the functionality that will reach out into the world and grab HTTP data or data from an HTTP service. So that'll be cached for some period of time. I think of all of OPA conceptually as a cache of data. So, so that's the one that jumps to mind. Yeah.
Okay, and specifically, again, one of the things that I'm seeing, and now I'm working on one of these, but I'm seeing more kind of like implementations of Zanzibar in the wild, right? Some of them are open source, some of them are SaaS, some of them are specific to companies like Airbnb and Carta. How do you think of like Zanzibar implementations and OPA together? Like, where do you think there can be some complements there?
Yeah, that's a good question. And again, I like to think of this as, I think it's useful to, as a point of comparison, to sort of think about OPA is really a stateless authorization service, right? It is a cache. It is not the source of truth for policy or for data, right? It is the thing you run in as many places as you want to make decisions quickly. When I think of the stateful services like Zanzibar, what I think of is things that are responsible for sort of being the source of truth for, let's say, permissions data. And so for me, those kinds of stateful services are going to be especially useful in like a multi-tenant app authorization kind of use case, right? Where you've got something like, GitHub is always my example for this one. You've got GitHub, you've got, what, are they up to millions of users, I guess? You've got millions of users, let's say, and millions of tenants, and each of those tenants can control what the permissions are for all the other users in their tenant. And so there's this sort of case where you've got this permissions data that needs to be stored somewhere. And so in those cases where you have that permissions data, having a stateful dedicated service is a pretty natural fit. In terms of how you could marry these two, like this stateful service and the stateless service, there are plenty of things we can do. You can imagine having the stateless service running at the edge, like as a sidecar with microservices that are making whatever decisions they can or it can. And then when it can't make that decision, delegating to a centralized service. That's a that's a pretty natural model that comes to mind.
Okay, and now let's kind of like step out of the OPA woods for a bit and kind of like dive deeper into Styra. We talked about like how you came to the space of like authorization through software-defined networking, but what made you create a company to do policy management, and who is your primary audience?
Yeah, great question. So yeah, when we started Styra, we've already sort of told you the origin story. We've already gone over this origin story and why we got it started. What we see really today is that we see a bunch of developer-like folks. So either DevOps or DevSecOps or really anybody who's administering these cloud-native software systems, and having to deal with the problems around. How do you manage authorization? How do you know who has access to what? How do you more importantly, I think, control who has access to what? That's something that we all do. And I think we would all do that better and have better security postures overall if we in fact had that unified solution to policy. So that's typically who we talk to. We talk to the people who have their core responsibilities are the safety, security, even the compliance of these cloud native software systems, and then up the management chain, depending on how far that goes.
Yeah, that makes sense. And from what you're seeing, what's making these companies like go the buy route, right? Again, OPA is open source. Anyone could go build some of the tooling that you're doing, that you're building. But what's making kind of like people saying, no, we're going to go with Styra, we're going to buy this solution. This is what we should be doing.
Yeah, well, there are a few things that we do at the Styra DAS level that that are pretty compelling to a bunch of folks. So one of which is that we sort of give you this end-to-end solution. So it's out of the box, right? You have a full policy management solution there available. So when you're authoring, testing, deploying, monitoring, looking at all the decision logs, there's that entire policy lifecycle management that we do as part of DAS. And then as part of that, what we also know is that you need more than a solution for an individual. You also need a solution that works for like an enterprise and an organization. And so therefore we have a bunch of enterprise governance features that allow you to say, for example, all the production Kubernetes clusters must have these 10 rules in place. All of the dev microservice apps have to have these other rules in place. I think of those two things in terms of like feature sets as what draws a lot of folks, that you do have this end-to-end policy management solution. that you'd have to go off and build on your own, honestly. And then over and above that, the thing that I always think about is that we've baked a bunch of the expertise, a bunch of the hard lessons that we've learned about deploying OPA into the software, and so they're not going to stumble over a bunch of things and struggle because it's already baked into this opinionated product.
Good. Maybe kind of like a curious question. What is a use case that you saw someone use OPA for that you would have never thought of before you started the company?
Oh, yeah. Let's see. The one that comes to mind immediately, just because it is one of those that's more surprising, was we had someone once use OPA to implement like the physics engine, I believe, of a video game, right? So not infrastructure, not applications, not CI/CD, had nothing to do really with cloud native. It was just they really enjoyed building video games and needed some way of encoding the rules that govern the game.
Wow, that's amazing. It would be very interesting to read a blog post about that.
Yeah.
How do you determine what features to build next?
Oh, here, we're pretty lucky in the sense that we've got a bunch of customers, we've got a bunch of open source users, and so we pay a lot of attention to them, and we pay attention to what people are doing in the open source. What use cases are popular in the open source. We chat with community members, and we understand what challenges they have. We do the same thing with our customers, and so we're pretty lucky that we can follow the open source in our commercial communities.
That's probably kind of like a good synergy opportunity between those two. Kind of like starting to close. Let's say again, someone listened to this. Someone's listening to the recording. How do you recommend someone learn OPA? What resources are available out there that you think, hey, these are the things that you should read?
Yep, I'll point you to a few things. If you want to learn Rego, right, the policy language, I'm a bit biased here because I built it, but we've got I'll say a good course, a great course on Rego on the Styra Academy. So that's it's like videos and it's quizzes and it's hands-on labs. So that's a great resource. There's also the OPA website, of course. It's got great docs. There's also the OPA Playground. So that's kind of a way of trying and sharing policies. And I'll finally point you to the DAS, the Styra's DAS product. You can sign up for that for free, and you can sort of see firsthand the vision is, at least as far as we built it, for unified authorization.
Yeah, that's great, and we'll add links to all of those resources in the show notes when we upload the recording. Final question: what are your biggest takeaways from this all of these years, your experience since you started OPA, since you built Styra up until today?
Well, there's so many things, I guess. I guess the one, maybe this is what I'll pick, at least for today, which is, I think we talked about this a little bit earlier, that this synergy between open source, general purpose, unopinionated projects together with a commercial opinionated offering is kind of nice in the sense that you get the best of both worlds. And I think that sort of balances, it gives people that really want something that's super easy to use, you've got the commercial product for that. For people who want to build things themselves, for people that want to go off and explore new applications or new uses of that open source, they can go off and do that too. So I really do like that balance, and I think it's I think we see that all the time. But I think going through the process of building these things out made that synergy especially obvious.
Yeah, that's great to hear. I'm happy to hear that as well. So again, this is all for today. We're over like 70 minutes of conversation. This has been really interesting. Tim, I want to really thank you for being here and talking about all of these things. It's been great. I'm sure people listening here and listening to the recording will really appreciate it.
This has been a blast. Thank you so much for having me. We should do it again.
Yeah, definitely. And for anyone listening, we are going to be doing a space next week with some folks from Airbnb about how they built a Zanzibar-inspired system to manage and centralize permissions. It's called Himeji. There's a blog post about it, and that's what we'll be talking about. So we hope to see you there. Thanks a lot, and stay safe. Bye-bye.